All right, welcome back. So, example 3 says, between what two consecutive integers is log of 7,598? So, since we know this is a common log, so it's log of base 10 of 7,598, we're going to go ahead and see what powers of 10, because that's what we were doing in the last video, was what power of 10 makes this number. Now, no power of 10 is actually going to make this number, because we know powers of 10s have all zeros after them. So we're never going to get here, but we want to see, okay, powers of 10, what could we do to get close to this number? Or what two consecutive integers will kind of get me below this number and above this number? So let's start listing out our powers of 10. So 10 to the first power is, of course, 10. 10 to the second power is 100. Still close, but not quite yet. So 10 cubed is 1,000. Okay, we're in the thousands, so that's good. We're closer to this number. Let's go 10 to the fourth power. That would have 4 zeros, so 10,000. Okay, so now we're actually already above this number because this is 7,000. So our 7,598 is actually going to fall right in between 1,000 and 10,000. Now I know you might be thinking, well, that's not very close to either one. Well, it's kind of close to 10,000, but it's just asking you, give me a ballpark, and this is honestly the best we can do because we have log of base 10 here. So between what two consecutive integers is this log? Well, the log of 1,000 is going to be 3, and the log of 10,000 is going to be 4. So the log of 7,598 is going to fall somewhere between those two numbers. So we would say it's going to be between 3 and 4. And the consecutive integers part, well, that just means one comes right after the other, and integers means, well, it's either, you know, whole numbers or their opposites. So we've done a good job here. These are consecutive integers. We wouldn't want something like 3 and 8 because those aren't next to each other. 3 and 4 is really what we want here. So we know it's going to be 3 point something, and I would venture to guess it's going to be closer to 3 point, like at the high 3s, so like 3.7, 3.8, just because your 7,598 is closer to 10,000. So it's going to be closer to the 4 mark, but in the high 3s. Okay? But they didn't really care about that. They just want to know between what two integers, so we can simply say it's somewhere between 3 and 4. So let's actually go ahead and figure out what it is using this guy. All right, and see if we were right. So log of 10, so we just use our common logs of 7,598, and see if we get 3 point something. Boom, 3.88. Excellent. So we were right, but don't write this answer down. They did not ask for an exact answer. They wanted you just to guesstimate where that would be. So that's how you would do this. You'd list out your powers of 10, and see where this would fall in between these. Okie dokie. So this next, it's not really an example. I just wanted to kind of show you a little something here about these graphs here. It says use your graphing calculator to graph y equals 10 to the x power and y equals log of x in the same window. So let's go grab our calculators. Please make sure you have yours if you don't have it already. Sorry, I just put it right there. Okay. So we're going to graph. Now remember, we did do stat plot yesterday, but that's not where we want to put equations. That's where we put data. So we probably have a mess in here, and so maybe do you from yesterday's work. So go ahead and clear everything out, turn your stat plot off, or else it'll mess things up. And we just want to put equations in here. So we're going into our y equals menu. So our first equation is y equals 10 to the x power, so 10 to the x power. And then our second equation is y equals log of x, so log of x. And then we're going to go graph. Okay, still have a messed up window. So let's go ahead and zoom standard, so zoom 6. And better, but they actually specify what they want our window to be. They say your x's should be between -2 and 12, and your y should be between -2 out and 12. So same for x and for y here. So how do we change that? If you're setting your window, you go to your window button right here. So click on window, x minimum. Well, our minimum here would be -2, so we put in -2 here. X maximum, we want to have 12 is the highest that we go, so we put in 12 here. And same for y's. The scales leave us 1, please. So y minimum is -2, and our y maximum is 12. Okay, and scales, resolution, just leave all that stuff alone. So we go back to our graph, and aha, that's a much, much better picture. Okay, now if you notice, these should look somewhat familiar to you from our work on inverses in the last chapter, because if you drew in the line, and you don't have to do this necessarily, but remember everything reflected over that line y equals x. If I go back to my graph, look at what I've got here. And I know the scales are a little funky because your screen is longer than it is wide, or is tall, excuse me. But if we reflected this piece and folded our calculator right along this line here, it should land right on top of this piece here. So what does that mean? I'm just going to get rid of this. What does that mean? Well, that means that these two equations are inverses of each other. Okay? Now our exponential one, remember from our work with exponentials, is going to go like this. So this one is actually our logarithm equation. Okay? So that means that y equals 10 to the x power and y equals log of x are inverse equations, or functions, let's say. Inverse functions. Okay? Which means one of them undoes the other. Okay? If you switch your x and your y, and I know this is weird because we don't really know operators with log yet, we would be able to come up with the other equation. Okay? So these are inverse functions. So let's take a look at a couple more properties that they have. Okie dokie. So we're looking at properties of y equals 10 to the x power and properties of y equals log of x. So I'm actually going to bring that calculator back out here. Let's focus on our properties of y equals 10 to the x power first. Let's get our picture back here. So that would be this equation. I'm just going to go back and turn the other one off for now, just so we can focus on the one. So our graph here, okay, so that's what we're dealing with here. This is our y equals 10 to the x power. And our domain, remember, was all real numbers. If I squish this to the x-axis, each side would be going on forever and ever to the negative infinity and forever and ever into the positive infinity. And then our range, remember, was positive real numbers, so we're not including 0 here. So we had, remember, never hit 0, but it does go up into infinity. Okay? All right, so since our graph never hits the x-axis, therefore the x-axis is what we call an asymptote of the graph, which is kind of a weird word. You might have heard it before, maybe not. But an asymptote essentially is a point where our graph is approaching, we're coming really, really close to, but it will never cross. So the asymptote is a line which the graph never crosses. Okay, so it's going to come really, really close, and the line is never going to cross, or the graph is never going to cross this line. Okay, and our y-intercept, if we have a base 10, is going to be 1 here. Okay, so remember we have our 1 is our initial amount, so our y-intercept is 1. So that means since our log function is the inverse of this function here, that everything that's true on this side, the opposite is going to be true for our log function. So let's take a look at that. I'm going to go ahead and switch this back to the other function. So we want to turn this one off and turn the other one back on. So then we go back to our graph. Okay, now that's the picture we're dealing with, which is kind of the exact opposite. So now our domain is going to be positive real numbers. Okay, so remember we squished to the x-axis here. We're never going to touch the y-axis now. So we have 0 to infinity, but we're not including 0. And then our range, if we squish this to the y, whoosh, that side would go up. This side's already pointing down into negative infinity. So we have negative infinity to positive infinity up here. So that would be our range. Notice it's exactly the opposite of what we had here. We just flipped these two, which is what inverse functions should do. They just flip. So then instead of the graph never touching the x-axis, we have the graph never touching the y-axis. Therefore, our y-axis is now an asymptote of this graph. So it's going to become really, 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 really close to this y-axis, but it's never going to cross. So that's also the same asymptote that was over here. And now instead of the y-intercept being 1, your x-intercept is 1. Okay, so your x-intercept where it hits the x-axis right here is going to be 1. Okay, so everything that is true for our exponential, and maybe you want to write that this is exponential. Is the opposite is true for our logarithm graphs. Okay, so definitely copy this graph down. You should be having all of these pieces of information. You do need to know all of this. Okay, but if you can remember one, it's real easy to remember the other. And most of this stuff we kind of discovered back when we were doing the graphs of our exponentials. Okie dokie. Example 4 says solve for x. We start out with log of x, so I'm going to say log base 10 of x, because we know it's base 10 right now, equals 1.5. So all I'm going to do is I'm going to rearrange this into my exponential form. So this is going to float over here and be an exponent for my base. So 10 to the 1.5 power should equal, and then remember the x gets bumped this way, should equal x. So this is easy enough. I just need to figure out what 10 to the 1.5 power is. So let's go ahead and do that. So let's get out of here. 10, oops, sorry. 10 to the 1.5 power, and that's going to give us an x of 31.62. Okay, and 2 places is good enough. I always like 2 places. So there's your x. So we know that the log of 31.62 should give us 1.5. So we can always go back and we can always check this. So do it the other way. So the log, if we plug it back in, we're going all the way back here. The log of 31.62 should give us 1.5. Does it, is the question. So log of 31.62. Now this is rounded actually, so it's not going to give us exactly 1.5. So let's actually forget that, delete all that out. Let's pull our answer. So log of second answer, this should give us exactly 1.5, and it does. Let's see what log of 31.62 actually gives us. It'll give us close, but not exact. So we've rounded, it's 1.4999. That's pretty darn close to 1.5. But if you pull that actual answer, it should give us 1.5 exactly back. So we're good. We know our answer works. So our answer here is x equals 31.62. So you want to have basically rewrite these in exponential form. So I would like you guys to try log of x equals 2.7. I want you to find x for this guy. So this is your turn. So your turn. And hopefully you'll come up with the right answer for me tomorrow. And I want to see it, please. So make sure you do this one. Thank you.